day, learners! Today, we are going to talk about kinematic equations of motion.
So what is distance? Distance is a measure of how far something traveled. Distance is a scalar quantity because we only measure the magnitude of how far we've traveled. For example, if I move the book 2 meters to the right, the distance will be 2 meters. Now, if I move it 4 meters to the left, then add a 2 meters from starting point, that will be a 6 meters. The distance, the direction we travel doesn't matter. So even though I move the book 4 meters in the opposite direction, the distance will be always positive.
Displacement is defined as the change in position of an object. It is a vector quantity that has a direction and magnitude. For example, if I move 6 steps forward and then 2 steps backward, what will be my displacement? So to compute the displacement, we will use the formula delta x is equals to final position minus initial position. Let's change the formula with our given. Our final position is 2, and then we subtract that from our initial position, which is 6. So my displacement will be negative 4 meters.
Speed. It is a scalar quantity that refers to how fast an object is moving. It is the rate of change of position of an object in any direction. Example, I run 360 meters in 60 seconds. What is my speed? First, identify the given. The given are distance is equal to 360 meters and the time is equal to 60 seconds. Then, we will use the formula. Speed is equal to distance over time. Next, substitute the following given. Then, calculate so we can get the speed of 6 meters per second.
Velocity. Velocity is a vector quantity that refers to the rate at which an object changes its position.
So, let's give an example. Let's assume a car travel at uniform with a distance of 100 meters in 4 seconds. What is the velocity of the car? First, let's analyze the given. We have distance 100 meters and time 4 seconds. We're going to use the formula velocity equals distance over time. Second, substitute the following. And lastly, divide 100 meters by 4 seconds. As a result, the velocity will be 25 meters per second.
Acceleration. It is the change of velocity of an object. The object's velocity will change over time. An example of acceleration is a motor starts from rest and moves 10 meters per second for 5.7 seconds. What is the acceleration? First, we have this the formula of acceleration, and it is A equals to final velocity minus initial velocity divided by time. Second, subtract the final velocity 10 meters per second and initial velocity 0 meters per second because it is at rest. Then divide it by the time, 5.7 seconds. So our acceleration is 1.75 meters per second squared.
The kinematic equation are a set of 4 equations that can be utilized to predict unknown information about any object's motion, if others' information is known. For my example, the given are only the final velocity, which is 0, the acceleration, which is negative 3.9 meters per second squared, and the distance, which is 290 meters. That's why I decided to use the formula BI squared is equals to BF squared minus 2AD. BI squared is equals to 0 meter per second minus 2 multiplied by negative 3.9 meter per second squared multiplied by 290 meters. The total will be 2,262 meters squared over second squared. Then, square root to get the final answer, 47.56 meter per second.
This time, I'm going to discuss the free fall. Free fall is the motion of an object under the effect of gravitational force only. Free fall does not mean that the object is falling down only. Objects thrown upward or downward are all examples of free fall. All free-falling objects accelerate downward at a rate of 9.8 meter per second. The following show the formulas in free falling. Kinematic equations of motion are also applicable for free fall because free fall is an example of uniformly accelerated motion. In short, the formulas in free fall or vertical motion are same with the formulas in horizontal motion. We just need to remember that in free fall, the acceleration is gravity and the displacement is height.
Example of free fall. Assume I drop a rock from rest off of a cliff and it hits the ground at 8.1 seconds. How deep is the cliff? First, identify the given in the equation. The given are time is equals to 8.1 seconds, gravity is equals to 9.8 meter per second squared, and initial velocity is equals to 0. Now, we will choose from the formulas presented earlier. In this case, since we are finding the height of the cliff, we will use the formula height is equals to initial velocity multiplied by time minus 1/2 gravity multiplied by time squared. Then substitute the given in the formula so we can get the height of the cliff, and that is negative 321.489 meters, or simply 321.489 meters downward.